It's time to start talking about React. We've covered the foundations now at this stage. So let's get into this kind of main topic, really. And again, my usual trick now is I did make some slight updates to these slides there yesterday, I think. So if you downloaded them last week, because they were available last week, there are some slight changes to them. So we'll just do a quick background on React, where it came from, and then we'll talk about something called JSX, which is one of these novel features that React introduced to us. Although JSX existed prior to React, really, but the React team kind of made use of this technology, and it's used by other frameworks subsequently. Then I'll say a little bit about the two main developer tools that we'll be using throughout this half of the module, one called Storybook, another one called Create React App. I'll talk about Storybook a little bit today, but to be honest, the one that we'll mainly use is the one called Create React App, which is quite easy to get used to, really. It's a command line tool. And then we'll talk about components, which are the basic building blocks of React. When you develop a React app, what you are developing are individual components, and you're gluing those components together, essentially. I'm also going to try and talk about something called material design at the end. This is something that I introduced there when I updated the slides yesterday. So we'll see whether we can get to that or not. So in very simple terms, as we probably know at this stage, really, if you've done any reading around React prior to today's lecture, it's simply a JavaScript framework, although some people call it a library, some people call it a framework. It's a kind of nerdy discussion that we won't get into. But essentially, it's we call it a framework, and it's very narrowly focused. It's completely just for building dynamic web-based user interfaces, no more, no less. Dynamic in the sense that you want your web interface to be to allow the user to interact with it, and that interaction will cause the user interface to change in some way. That's what we mean by dynamic. A more technical statement of what React is to say that it is a single-page app framework. And again, when we get into the detail of developing React applications, I'll explain where that kind of term comes from. Now, as you probably know, React is associated with Facebook, but it originated in the Instagram organization. It was an in-house project, if you like. A lot of open source tools and technologies actually begin life as an in-house project, and then the organization kind of abstract from it, and sometimes they open source it to make it available to the rest of the community. And that was kind of the case with React. It began as an in-house project in Instagram. Then, as we know, Facebook acquired Instagram. They took that in-house product, not sure what they called it at the time, but eventually they decided to open source it around 2012. And that's how it is available to us really today, I guess. So it's been around for quite a while. Whether it'll be around in 10 years' time is highly unlikely. Something else will take over. So that's the nature of the industry that we're in, I'm afraid. Now, so React is a single-page app framework, but it was by no means the first single-page app framework. There are many that predate it. I think the first one, certainly the first one that I came across was is a one called Backbone. It doesn't exist anymore, but there are other ones that you may have heard of. Ember is another one. Angular, you definitely would have heard of. Now, Angular 1.x, there's a new version of Angular, well, new as in the last 5 or 6 years, called Angular 2. But Angular 1 and Ember and Backbone all kind of predate React. So React certainly wasn't the first into this space. But it has kind of emerged right now anyway as being the market leader, if you like. And what set it apart from its competitors at the time, it made a number of the React design team made a number of decisions which went against the grain at the time, and maybe that's a reason why it actually became so popular. There are obviously good decisions that they made. One decision they made is that they weren't going to follow the MVC pattern. MVC for model view controller. I'm sure you've heard of it. along the line somewhere. Essentially, it's a pattern that guides you into how you should break up your overall application code into model parts, view parts, and controller parts. All of the single page app frameworks that existed back around 2012 and prior to that, they did follow that pattern, but the React team decided that they weren't going to follow it. In fact, they kind of narrowed the focus of React. They only concentrated on the V part of MVC. So that set it apart. Also, if we just think about the V part, V for view, the view part of developing web-based applications, most of the frameworks that existed at the time followed a templating approach, and the React team decided against that as well. It doesn't really matter whether you have any experience of templating or not. The React team decided that they weren't going to use templating. They said that they were going to base their whole framework on the notion of components, which is where we are today. Now, the table just shows you, and I've only put it in for completeness sake, really. I'm not going to dwell on it too much, but essentially the argument that the React team made at the time as to why they went for the components approach as opposed to the templating approach, and why they just focused on the V part as opposed to the MVC part. Essentially, they kind of argued that you get better separation of concerns as a result of these decisions that they made. You get better separation of concerns in your own code. You get better reusability of the code that you develop. And also, because React is just using HTML and JavaScript, whereas the templating approach required you to learn another kind of syntax. But because with React components, you are just using JavaScript essentially, and JavaScript is a fully fledged, very powerful language. Then you had a lot more expressiveness in your code base, or you could express a lot more in your components than you could using the templating approach. So these were the reasons behind why they made the decisions that they made. Again, let's not dwell on them. So React is all about building components as opposed to creating templates. And secondly, then we now know that React is really only about the user interface. It doesn't concern itself with the M part of MVC, the model part. The model part is very important, but the React team decided that they weren't actually going to address that. By the model now, I kind of mean that when you probably bring data down from a server side and you need to manage that data within your browser, the React framework doesn't help you in that regard. You have to use maybe some other framework to do that. You may have heard of a framework called Redux. That's a very popular framework for looking after the M part of MVC. The C part doesn't really play a role at all. So React is really only concerned with the user interface. Now, that kind of story has slightly changed in recent years. By that, I mean that the React framework is extending now into the M part of MVC, and we'll see that in a couple of weeks' time, really. So that story has changed from the outset, or from the initial kind of objectives of the framework, if you like. And so it's all about components, and the component is the unit of composition, as we say. And a component, because it's only concerned with the V part of MVC, a component is made up of two parts, if you like, the UI description and the UI's behavior. Now, by the UI's description, we simply mean HTML. That hasn't changed. That's still the language of expressing how our user interface kind of looks in terms of layout, etc. How the UI behaves, well, we're going to implement behavior in JavaScript, obviously. Okay, so those two elements make up a component. And what was different about React at the time was that these two elements, the UI description and the UI behavior, were co-located in the one physical file. That was different in the templating approach. In the templating approach, you put your behavior in a JavaScript file, but you put your template in a different file, and you found yourself flipping back and forth between the two. So they made a conscious decision to actually co-locate the two elements that make up a component into one physical file, and that was quite novel at the time. The benefits of all of this, they argued, was that you get improved composability, the ability to join components together and get them to work with one another. Greater reusability, which I've also mentioned before. And well, the third point there about better performance has not so much got to do with the fact that components are being used. It's got to do with something called the virtual DOM, which I'll talk about in the, maybe I think in the next lecture or the one after that. So this is all a bit waffly now, I appreciate. So let's narrow it down a little bit. So I said that a component has two parts to it, and a component is only concerned with the user interface. A component has two parts to it, the UI description and the UI behavior. We needn't worry about behavior for now, because that's just going to be JavaScript, how we want to the component to react based on the user's interaction with it. How do we actually code a component's description in terms of its layout, etc.? Now, the React framework is actually broken up into a number of modules. One is called the React module, and the other is called the React DOM module. And the React module has a method called createElement, and you use that method to create a HTML element in code. Okay, you can programmatically create a HTML element. So you would use the React.createElement method to do that. The React DOM module has a method called render, and what it does is it will attach an element to the DOM. Now, Frank spoke to you about the role of the DOM in the browser 2 weeks ago. So that's central, obviously, to anything that we do in a browser. Okay, so how do we use these two methods? And let's look at them one by one. So the createElement method takes a number of arguments. You've got to tell it what type of element you want to create, what kind of HTML element, H1, a div, a span, a button, etc. You've got to tell it what properties you want to associate with that element. Properties, for example, would be if you want to associate some CSS styling with it, if you want to associate an event handler with it. And number 3 then is what children, if any, does that element have? As we know, HTML allows you to nest elements within elements. And so we need to be able to express that programmatically using this method called createElement. Here's the catch though. If you're worried now that we're going to be using this very kind of imperative approach towards building or coding a UI's description, the answer is we won't. So I'm showing you something that we won't be doing, but it is happening behind the scenes. And I always think it's a good idea to have some sort of understanding as to what's happening behind the scenes. So React.createElement is very much active behind the scenes, but we won't invoke it directly. Let's carry on anyway. That's the React.createElement, and I'll show you an example of it in a second. The React DOM.render module, it's pretty straightforward. It takes 2 arguments. You pass it a reference to an element that has been created by the previous method, and you need to tell it where on the current DOM do you want to attach that element. Because if you don't attach the element to the DOM, then the user can't actually see it. Let's look at some examples. Now, the examples that I'm going to step through, you can get from this archive here. If you just click that, it'll download a zip, unzip it, and import it into VS Code. And so here it is here. So I've just got a couple of HTML files, good old-fashioned HTML files, which we'll step through one by one. And inside them, as you will see, we're using these 2 methods that I just mentioned. Just by the way now, just in case some of you haven't done any JavaScript coding, within recent years, just to give you a little bit of background. So when you've got a JavaScript project, this is what this is. And if you are using any third-party libraries, then what you do is you create a file called package.json. And inside there, this has to be structured in a certain way. but there's very little in this one. But you see here that you've got to specify, amongst other things, what third-party libraries are you using. In other words, what is your project dependent on? What dependencies have you? And you can see here I'm dependent on the React module and the React DOM and particular versions of them. And again, I'm assuming this is just for those people now that may not have done any JavaScript coding recently. What you've got to do, and this it's specified in the README, actually I explained it in the README, but what you've got to do once you've imported it into VS Code is open up a command line or an integrated terminal and type the command npm install. And what the npm install command does is it goes looking at this package.json file, it looks at the dependency sections, and it essentially downloads the various third-party modules that you require. It downloads them from known repositories that it's aware of. Now, I've done that beforehand, obviously, and the modules will be installed locally, and they'll be installed inside in a subfolder called node_modules. And lo and behold, if we look through here, we'll find the React and React DOM, amongst a few other libraries as well. So you never need to go near node modules, but that's what's happening behind the scenes. So I've installed my React and React DOM third-party libraries. Now let's look at what's going on inside these HTML files. And in order to do that, we will start up our live server that we installed in VS Code from a couple of weeks ago. So I click off, I'm going to close that first actually. Click off my live server. And so it's now, because there's no index.html in the base folder of my project, it's just giving me the contents of the actual project itself, if you like. And so let's start from the top of the 01 file. I click on that. It renders that. So how did that happen? Let's look inside 01, index.html. It's a standard HTML file, nothing special about it. The only HTML in the body is this line here, a div. There's no other HTML. So what is being rendered in the browser there isn't coming from the HTML that's in the file. So it's coming from somewhere else, and it's coming from my JavaScript code here. I'm obviously have to reference the React and React DOM modules that I've downloaded because I'm using those inside in my custom JavaScript here. And so here's where we're interested in this kind of code here. So if we take it in small steps initially anyway. So this, I'm using the React.create element. It looks like to create a H1 HTML element. The way you interpret this line here is, you know, in HTML, you can have a HTML element can have a class attribute, and you can specify some CSS classes with the element. Now, because the word class is now a reserved word in JavaScript as of ES6, then we can't use the HTML attribute of class when we're using React. So what the React team decided was to use the name class name. So whenever you see class name associated with a React component, it's really referring to CSS, a CSS attribute that you want to associate with the element. And I'm referring to a CSS class called heading, and that's just inside. I've got a local CSS file here. So there's my heading, which, you know, we're not too interested about the CSS, but that's where it's coming from. Back to my file. So I'm creating a H1 element. I'm associating some CSS attributes with it. And that's the text that I want to associate with the H1. That's fine. Here I'm creating, it looks like I'm creating 3 HTML LI elements. They don't have any attributes in this case, kept it simple, and that's the text that I want to associate with each of the li elements. Next, I'm creating a ul element, no properties, but this element has 3 children, and the 3 children being the 3 li elements that I have here. So this is a good example now of React.create element, of using React.create element, where you want to create an element and it has a number of children, and you just specifically reference the children in terms of the variables that are assigned to those children. Moving on, I'm creating a div, some CSS, and my div has 2 children, the header that I created at the top, this element here, and my list of languages essentially. Okay, so all I'm doing so far is just creating some HTML elements. Nothing is visible so far. This line here is what makes those elements visible to the user. So I'm using the React DOM.render method. I'm telling it I want to attach this element to the DOM. This is referring to this here. So that essentially pulls in everything really because of the way I've structured my code. Now, the second thing you've got to tell the render method is where do you want to attach it to the DOM? And this piece of code here is actually very old JavaScript browser-based code. But essentially what it is saying is it's telling the browser, go find a current element on the DOM whose ID is mount point. And that is the div that I mentioned up here. So I want to attach it to that div. And now having attached this element and all its children to the current DOM, that's what makes it appear in the browser to the user. If I simply comment out this line, comment out the line and save it, and because of my live server now, it reloads it in the browser. If I go back to the browser, now nothing is visible. So that kind of proves the role of the React DOM.render method. So that's essentially very low-level React coding. Just going to pause for a second if there are any questions. No.
No.
Okay, so look, it's very procedural. It's very long-winded. Not very pleasant to program in this style.
Quick question.
Sure.
That create element, does it have to be a proper HTML type of tag?
It does, yeah.
Okay, so it won't take blah or something like that.
It won't take what, sorry?
Like a foo or something like that. You know, it has to.
I've never played with it. I suspect if you gave it something it didn't recognize, then it just wouldn't render anything in the browser. That would be my guess. Okay. Yeah. Okay, so that's, even though we never program in this, as I said, every code, any React code that we will develop using what's called JSX, which I've yet to talk about, all of that JSX syntax will actually be transpiled using Babel, which I've mentioned before. It'll be transpiled back to this type of code. So we don't have to write this type of code, but this is the only type of code that the browser understands. So it needs to be converted into this for us, and Babel will do that for us. Now, the 02 file is displaying the exact same thing. I think if I click on 02, right, and what's different in 02, essentially, before I look at 02, like I could take a few, make a few slight improvements to this code procedure and all as it is. For example, rather than using that there, I could just say, why not just bring down the code that you're assigning to Heather, because we never use this variable again. Why not just take this code and stick it down here. Save that. It'll still render okay. If I go back to 0, 1. 0, 1. It still renders fine. And I could keep on doing that. By that I mean I could take the list variable here and replace it with the actual code that I assigned to it. And equally, I could take item 1, item 2, item 3, remove those variables and just substitute in what they are actually being assigned. And if I keep on doing all of that, what I finish up with is what is inside in 02. So in the 02 file, I've just created one variable, and I've nested my React.create element invocations in the way that I was demonstrating there. Yeah, so that's all 02. It's the only difference between 02 and 01. Just slightly, I just have less local variables, but other than that, it's not a great improvement. That's 02. Okay, so I've introduced the demos to you, so I don't need to. So what I've been illustrating is a kind of imperative approach towards building our user interface using the React framework, which is not developer friendly by any means. And so that's where this JSX comes in. JSX is an extension to JavaScript. It's a separate library actually, and it predates React, but the React team leveraged it. And what JSX allows you to do is, rather than implementing your user interface description imperative or in a procedural way, you can implement it using a declarative syntax. And it's always easier, arguably anyway, to code stuff up declaratively than in an imperative or procedural way. And what's nice is that JSX, because it is an extension to JavaScript, we don't lose any of the power of JavaScript. When templating was being used by other frameworks, templating had its own kind of syntax, but you kind of lost a lot of the power of JavaScript as a result, which is why the React team went the components and started using JSX. They went that route. And our JSX, which is what we're going to use to implement our UI description, it can be, as I've already mentioned, it can be co-located with the JavaScript that is implementing your UI components behavior. But this JSX syntax, which is really, as you see, it's very HTML-like. And so it essentially kind of allows us to mix HTML and JavaScript in the one physical file. But of course, the browser doesn't understand this JSX syntax, so it has to be transpiled back into plain old JavaScript. In other words, it has to be transpiled back into the kind of code that I've shown you up to now. So let's look at 03, and I've purposefully included the label error in this file because this won't work the way it is at this stage. But anyway, let's look at 03 HTML file. Kind of the same objective that I want to achieve. And so here's my component description implementation. So I'm declaring a variable and I'm assigning, okay, technically this is JSX, but there's nothing special. Well, other than class name, I suppose that's what distinguishes it from ordinary HTML, but it's essentially a piece of HTML that I'm assigning to a variable. and I'm passing that variable to React.render as I did before. So this is what JSX looks like. This is our first look at JSX, and there's no surprises in there, as I said, because it's very HTML-like. Now I've got that code buried inside in an ordinary HTML file, but if I send that file as it is down to the browser, it won't be able to interpret it. And not that you don't believe me, but just to prove it. So if I click on 03, and I'll open up my developer tools because I know the browser is going to throw an error. So when the browser tries to execute my JavaScript script, and it hits this symbol, the less than symbol, and it says that that's a syntax error. It doesn't recognize it as ordinary JavaScript, and that less than symbol is this one here. Okay, so what do? What we need to do is we first of all need to transpile this, and I've done that. And literally what you could do if you were doing this manually, which of course we won't be because that's going to be too slow, but to do it manually, I could just grab this code and go to that website that I mentioned to you, was it last week? The Babel.js tool, because it actually can take React JSX syntax and transpile it for you if there are no errors. What doesn't it like? Did I miss something? No, I didn't get the full, I think. Oh yeah, there we go. So you can see on the right, okay, there are some annotations inserted as well, but you can see evidence of React.createElement in the transpiled code. And so what I did was essentially I copied this code into a JavaScript file. That brings me on to sample 4. So sample 4, we are now referring to just an ordinary JavaScript file that contains my transpiled code. And that'll bring me up to this folder here. And just for your own sake, what I've kind of done is I've included two files with 04 prefixed. One is the pre-transpiled and the other is the post-transpiled. So the pre-transpiled is, that. So this is what we write. And this is what is sent down to the browser. So my 04 JSX is referring to this file here. And now, obviously, everything is going to work fine. Okay. So JSX is this HTML-like, technically it's XML, but it's this HTML-like markup. And of course, we're familiar with HTML, so that's what was nice about React. We didn't have to learn a new kind of syntax. There would be a little bit of learning maybe, but for a beginner anyway, we could get into doing some simple JSX component implementation. Now, we haven't really seen a component yet, right? There's another step before we get to that. Or we're looking at now is one part of a component, which is this JSX syntax. And I've kind of already mentioned that, there are very, very few differences between HTML and JSX. And I think the only one that you will come across is certainly the only one that I've come across, and I've done a lot of React implementation over the last couple of years, is where you don't use class when you want to associate a CSS style with a particular element, you have to use the class name attribute. And you get an error usually from the browser anyway if it sees class, or sorry, will you get it from, I think you get it from the browser. Well, that's only if you had a plugin maybe. You would get it at the transpilation stage anyway if you use class within your JSX syntax. Other than that, everything that you already know about HTML kind of applies. Okay, there's nothing new there, I don't think. So JSX has to be transpiled, and fortunately there is just one tool to do that for us, which is the Babel tool. How do we do the transpilation? Well, I've shown you there that you could do it manually using that online site, but of course that doesn't scale, but it's fine if you're just playing around with it. And I still find myself going back to it every now and again if I want to see, well, how does this piece of JSX actually compile down to plain JavaScript? But other than that, it's really fine for a learning tool, but it's not if you're doing kind of proper development. There is a command line tool that you can install as well, but equally that's not scalable. Option number 2, which is what we will find ourselves using throughout this module, is you can get web servers that have special instrumentation built into them, where that instrumentation essentially takes all of your JavaScript files and transpiles them as you're kind of updating them, and sends the transpiled versions of your code down to the browser. Does that kind of live reloading that the live server that we've seen do as well. These special servers actually will perform live reloading. So essentially the transpilation will be going on in the background. So when you're in development mode, you kick off one of these servers in the background and you just carry on doing your development. And every time you save a file, the server will spot the change that you've made, or it will be alerted to the fact that you've made a change to a file. It'll retranspile it, and it'll send the updated version of the code down to the browser, and the browser will reflect that change in whatever it's displaying in to the user. If you're familiar with Webpack is being used by these special servers to carry out all of this live reloading and live retranspilation for us. That's when you're in development mode, but eventually, presumably, you will want to deploy your React app for the rest of the world to use, if you like. So you've got to build a kind of a production version of your app. And there are tools as well which will do that for you, which we often refer to as bundlers or just build tools. And what these build tools will do is they will essentially take all of the JavaScript files that make up your React project, and they will bundle them, they will transpile them, and then they will package them into one JavaScript file, one bundle or one unit. And that then becomes the thing that you deploy to whatever cloud platform that you use, plus maybe some other assets as well, plus maybe a shell index file, some images if there are images, some raw CSS if there happens to be some raw CSS. You'll actually see 2 and 3 in action in the second of this week's labs, and we'll be using 2 then throughout the remainder of my lectures with you. So back to components though. Where does this fit in terms of components? So it turns out that a component, a React component, is simply a JavaScript function. Back to our functions. That JavaScript function, we tend to code them using the arrow syntax, but it doesn't have to be. You can use function declarations, function expressions, doesn't really matter. But it's a function, and it can have any kind of logic in the function that you want to, but critically, the function returns the UI description associated with that component. In other words, it returns a JSX snippet as part of its contribution to an overall application's user interface. So that's what a component is. It's a JavaScript function that returns JSX. And what's nice is that you could kind of think of React as a way of extending the syntax of HTML itself, because when we implement a component, and we haven't implemented one so far, when we implement a component, we can refer to these components in the rest of our code. For example, if we want to pass a component to the React DOM.render, we can refer to it as if the component is an actual HTML element. We can use this kind of syntax to refer to the component, which is kind of nice. So that brings us on to sample 05. And all my samples display the exact same thing. That was kind of intentional, really, but so 05 is that. And the code, now in the HTML, it's not too interesting because we're simply just referring to a file that contains our component implementation. And if I look up at the JavaScript folder, again, I've got two 05s. I've got the 05 file that we develop as developers, and I've got the 05 JavaScript file that is sent down to the browser. In other words, the pre-transpilation, post-transpilation, or I call them here, the source and the transpiled. So the source is what we implement. So here's our first component. And indeed, I am declaring a function here, an arrow function. I've decided to call my component dynamic languages. There is a convention, by the way, that React components should be capitalized. It's convention only, but you should follow it. Now, in my component implementation, I don't have any behavior, if you like. That's certainly going to change. So, sorry. You can have any other JavaScript code that you want to inside here, but it doesn't apply in this case. So this component is static, we would say. It has no dynamics associated with it. And indeed, as I said, it is returning some JSX, albeit very static JSX, with the exception of that. So that's what you implement, and then you get Babel to transpile it. You know, we don't really need to go look at the transpile code anymore because it doesn't really help us, but that is the transpiled. Again, I did the same thing. I took the source code for that component and I copied it into that babel.js or babel.js.io website, and it did the transpilation for me there manually. It took the copy of the right-hand side, and this is what I come up with. Okay, and again, as I said, there isn't really much point in looking through that because the compiler does what the compiler does. So that's what we implement, and here's my component. And the only thing, I suppose, again, is this line here. I'm attaching that component to the DOM, but now I'm referring to the component rather than referring to an ordinary variable. I'm referring to it as a HTML element, if you like. Pause for a second if there's any question.
You can put attributes and things into that that
Yeah.
custom tag.
Yeah, that's what we call them props. That's where we start making components reusable, because now it's completely static. Like the languages is obviously, we'd like to be able to pass in the list of languages to the component. And that's, as you said, you would do that by means of attributes that you would specify here some way. In fact, we'd specify them. They're just key value pairs. They're attributes in the same way that we associate attributes with a HTML tag. So they've tried to remain as much as possible anyway. They've tried to remain consistent with the whole HTML kind of flow, look and feel. Right, a slight change of tack now for a few minutes. We'll come back to components though, because all we have so far is a static component. And as you just mentioned there, we'd like to be able to maybe pass some attributes into the component and refer to those attributes inside of the component code. So we need to look at how that's going to happen. But before I do that, I want to talk a little bit about the tools that we're going to use when we're doing our React development. And there are two. One is called Create React App, and as its name kind of suggests, this is a tool for creating an entire app in React. And so it comes with a number of features, all of which are fairly familiar if you've done any kind of modern app development. Number one, the Create React App tool will generate a skeleton folder structure, and in fact, it'll generate some other code as well. So it'll essentially construct the scaffolding that is necessary for a React app based on kind of best practice. And really, Create React App is the dominant tool out there in the industry for React development. And it also comes with its own development server, which I was talking about a while ago, the development server that will take care of transpilation and take care of live reloading any changes that you make to your source code, live reloading them down to the browser. Because presumably, as you're doing your React development, you want to see, well, what effect does this code change have on what I see in the browser? We want that kind of instant kind of feedback, if you like. And the development server that comes with the Create React App tool will allow us to do that. It'll spot the changes when you do a file change. It'll do the retranslation of the particular files that have changed, and it'll send only the updates. It doesn't send a full kind of refresh of the app down to the browser. It'll actually, as we say, it'll do what's called hot reloading or hot kind of swapping. It'll only update the parts that need to be updated down in the browser. Thirdly, it comes with a build tool as well, which will build a production version of our React app. And you'll do that in the second of this week's labs. That's Create React App. Sorry, I thought somebody had a question there. The second tool is called Storybook. And Storybook is kind of everything that Create React App is not, in the sense that Storybook is a tool that you would use when you want to develop a single component or individual components. And you just want to know, well, how does this component render in isolation? I don't want to attach it to a big app yet. Eventually you will. But I just want to see, does the component behave and look properly in isolation from everything else? And the Storybook tool will support you in that task. So Storybook is a development environment for React components. And it, as I said, it kind of allows you to essentially focus on the component itself without worrying about the environment that the component might be deployed in. And arguably, it encourages you to develop more reusable components, which is obviously a good idea. And there is a kind of quicker development experience as well, because you can get much quicker feedback in terms of what the particular component, whether it is behaving the way you want it to behave and whether it looks the way you want it to look, without having to worry about all other components that might exist in a larger app. So Storybook essentially is a separate npm install, and you install it like you install all npm packages. So it's a standalone tool, if you like. And there are two parts of when you install this tool. Yet again, Storybook comes with its own server, which does all the things that I've already spoken about, that these kind of development servers, we'd like them to do. So it has its own development server. And secondly, it has its own kind of user interface to allow us to essentially look at individual components and play with them, if you like. So when you install Storybook and you kind of attach it to maybe a project that you're working on, when you start up the Storybook server, it will fire up a browser tab, and it'll find all of the components in your project. You've got to tell it where they are, obviously, but it'll find them. And what it does then in the browser tab is it renders its own user interface, which looks like this. So this is Storybook's own UI now. And what you see on the left is all of the components that it found in your project. And these are going to be clickable. And when you click on them, it'll show you on the right how that component renders for a particular data set that you might have specified for the component. So as I said, you can actually see and concentrate on one component at a time. Now, where the term or where that name kind of Storybook comes from, it actually comes from user stories. If you're familiar with the whole area of user stories in user requirements analysis, you may or may not be, but that's kind of where the origins of the name comes from. But to just expand on it a little bit, what do we mean by a story in the context of a React component? And it turns out that a component can have or may have a number of states associated with it. And the state may actually influence how the component renders, or it may affect how the component renders. So each state is what we refer to as a story. And so that's where the name kind of Storybook comes from. So this whole idea of kind of trying to identify what are the different possible states for this component that I'm developing, that's really part of the design process that you would go through when you are developing a React component. Now, just by way of example, now to be honest, the vast majority of components that you will develop, arguably anyway, will only have one story. So in a sense, there won't be multiple states, and you have to worry about multiple different types of renderings of the component. You may have one or two that has more than one state, but the vast majority of them will just have a single state. But if we think about the dynamic languages component, which I've just illustrated to you there a few moments ago, and if we just expand out what its requirements might be, supposing we were told, well, we want the component to render slightly differently depending on how many languages it has to list. And we're told that if there are 5 or less languages, then we want the component just to render those languages in the way that it currently is. Maybe it doesn't get any languages. We're assuming now that the languages can be passed into the component, which we have to see how it's done, but that's okay. So if it's passed in an array of languages and there's 5 or less, then the component should just render them as is. If it's passed in an empty array, then rather than the component rendering nothing, then maybe it should render some sort of informative message back to the user, something like that, no languages. And thirdly, if the component gets an array with more than 5 languages, then we've decided that it will just display the first 5 and maybe have a kind of a link that will allow you to click, the user to click and display the next 5, that kind of pagination type behavior. So they now would constitute 3 different states for my component. And I've decided just to give each of the states a kind of a arguably meaningful name. Okay, default, boundary, and exception. So I've got 3, I would say that I've got 3 stories now, or 3 states associated with this component. And I've got to take that into consideration when I'm implementing the component. And I've got to see, does the component render the right way for each of the 3 possible states? Now, so when you are using Storybook, you are doing 2 things. You're developing your component, but you're also implementing the stories associated with the different states. And I'll show you how you code that. You implement them in JavaScript. It's quite straightforward, really, even though the syntax looks a little bit complicated at first viewing, but not when you break it down. So you implement the stories, and the stories for this dynamic languages, one would be you'd have one story where the array is 5 or less, another story where the array is just empty, and a third story where the array is more than 5. And what's nice about Storybook is that it will actually reflect that in the UI. And that's what I'm showing you here by way of example. It'll show you that, well, this component has 3 states associated with it. And now these are clickable. And when you click on them, you see how the component renders for that particular state. So this looks like I'm looking at the state when the component is given more than five languages. And so the whole point of Storybook now is that it allows me to make sure that my particular component is working properly before I start attaching the component to a larger app. Storybook is actually as well, in a large software house, you could have a very large catalog of components that have built up over the years. And it would be nice if we could point Storybook at the catalog, and that would allow us to look through the catalog to pick out components that maybe we could reuse for a new project that we're embarking on. And Storybook allows you to group components into groupings, and you achieve this in the actual stories, the way you write the stories, as you'll see. So I'm just giving you an illustration of it here. So I've cataloged my components into meaningless, admittedly, but you'd give them some sort of meaningful labels just to make it easier to look through the catalog. Now, as I said, you have to actually implement these stories, and you implement them in JavaScript. And that's what I'm showing you here. So this is a JavaScript file that implements stories for a particular component. It looks like my dynamic languages component. And we don't look we're not interested in the detail, really. We're interested in the outline as to how you structure the story implementation. So if we just take it from the very top, you obviously have to import the React framework because React is being used. Here is where I'm using the Storybook tool that I have installed. There's only one function really that you need to be aware of. It's a function called the stories of function. And I'm obviously importing the component that I'm implementing stories about. And so here's how you implement your stories. So you call the stories of function. You pass it a string. Now the string can be anything, but I suppose it would be sensible if the string reflected the name of the component that's being rendered, but it doesn't have to be an exact match. There doesn't have to be an exact match between that and the actual component name that it's up here, but it would be sensible that it would. I wouldn't worry about the second argument. And then what you've got to do is chain on invocations of the add method. So I've got an add method here for each story. Okay, so we're using this method chaining coding style, which we saw last week in a different context. And each add method takes 2 arguments. It takes essentially the name that you want to associate it with the story. Again, it's a string, it can be anything, but give it something meaningful, I suppose. The second argument is a callback function. And the callback function is the implementation of the story. And there's usually very little in the implementation of the story. What's really important is that this callback has to return the component that's associated with the story. Now, in this case, as you can see, this first story looks like it's the story where I'm passing an array of less than 5 languages. So I'm just creating my array here. And as one of you asked there a moment ago, here's actually how I pass my array into my component. We'll explain the detail of this a little bit further on today. But we can just take it for now that I'm passing my array of languages into my component. And the component hopefully renders properly. So this is one story. And then you chain on an add invocation for each story. And I've left out the detail because it's not important. So that's how you implement stories using the Storybook tool. And so when you start up the Storybook server, it goes looking, it essentially interprets all of this code. And that's what allows it to generate, this kind of output here in its own user interface.
So sorry, but where's the JSX? Is that sitting in this file?
Sorry, ask that again.
The JSX part of it, where does that, is that in this file?
That's inside in this file here.
Okay.
Yeah, that's where I've implemented my component. So there's two things.
So this thing is a like a configuration for story.
You could treat it like that. I prefer to refer to it as the implementation of my stories, because my stories will drive how the component renders in Storybook for me. You know, these story implementations here, they are what A generates this kind of listing over here, and B determines how the component actually renders over here. So I guess it's you write your component first, or you may do it in stages. You may say, okay, I'm only going to implement the first story in my component. Take it in small steps. So I'll implement the part of my component that expects 5 languages or less. So I go away and I do that coding inside in this file here. Then I come over to this file, my stories implementation, and I just write from here to here. That's all I've implemented, one story, because my component can only handle one kind of use case, if you like. Having written that story, I then start up the Storybook server. And what the Storybook server will do is it'll open up a browser tab. It'll read this code. And based on what it's read here, it will generate this line here and this line here, nothing else. And I can click on this. And when I click on it, then I will see, well, is my component actually working right or not? Is it generating the right user output, the UI output? And then you go back to your component and you expand it or correct it if it's not working right. And you're going between the component implementation, code implementation, and the story implementations. And that's how you're building up your component until it's finished. And then you either use that, if you're happy that the component is working properly, then maybe if you're in the middle of a React app implementation, you can now use that component in the actual application itself. You may still have problems, but at least you know that you've solved some of the implementation issues associated with that particular component. So that's kind of there or thereabouts. That's kind of the developer kind of process, if you like. And the stories of function, you could have multiple invocations of it within the one file. That's perfectly acceptable. It's kind of up to you as to how you want to structure the files that make up all of the stories for all of your components. You could put them all into one file, probably not a great idea. You could break them up into files at a component level or at a group level. It's really up to you. But if it is at the group level, then the first argument to the stories of method is a string, but there is that you can control how the components are grouped by using this slash symbol. So that slash symbol there can be interpreted by the Storybook server and can help it to work out how you're actually grouping your components. So this is telling Storybook, well, I've got a group called that, and one of the components in it is going to be this. And you can see down here, I've got another separate story which begins the same way, but a different component name, and so on down along. So by structuring the string that you actually pass to the stories of function, that's what controls this kind of grouping that goes on here. Okay, back to components though. And we want to make our components reusable, and we want to make them dynamic the dynamics won't actually come in until next week, unfortunately, but there's still a little bit of ground to cover before we get to that. Now, I've got a series of samples that I want to just step through, and these samples actually form part of the first of this week's labs. And what I'm showing you here on the screenshot is how I've kind of approached demonstrating the samples, and this will be, as I said, part of the lab. So if I now, and you'll get the zip file associated with these demos from the actual lab itself. And so what you will see is you get a zip that you download and unzip it, and you get this folder here. So if I just import that into VS Code, just going to do a cleanup first. Now, let's just look through the files actually first, and it might help you to understand what I'm kind of structuring here now. So this is not a React project now. I've just got a couple of components inside, and sorry, it's not a React app. It's just a small little JavaScript project, if you like. So I've got a components folder. So obviously it's in there that I have implementations of components, and I've got a stories folder, and it's in there. I have my implementation of my stories. I've got this other file up here called .storybook. That is going to be my storybook configuration location, and there's very little in there. In fact, and it's something you never need to go near. There are two files. There's nothing in the first file. I think I should have left it out really. This is the main storybook configuration file, and there's very little in that as well. You can see there on the right. The only thing you've got to put into this file is you've essentially got to tell Storybook where are the story implementations, where are they contained within your project folder structure. And this is essentially telling it, go look inside the stories folder, this one here, and look for files that are ending in .stories.js. By the way, there is no requirement that your story implementations have to be in a file with this extension. In fact, in most cases, if you start reading articles around Storybook, in most cases, they're just ordinary JavaScript files. The .stories part, I don't know where I came across that. I think I might have come across it somewhere and I just used it. But so the configuration is you've just got to tell it where are the story implementations. And so what happens is when you start up the Storybook server, which you do from the command line, which I'll do in a minute, it looks at this configuration file. That tells it where the story implementations are. It then reads through these two files, and inside these two files, as well as the story implementations, you will obviously have references to the various components, which will bring it up to here. And it's inside here then that you have your component implementations. So it essentially kind of gobbles up all of that code, both the story implementations and your component implementations, transpiles all of that, opens up a browser tab and starts up its own Storybook's own user interface in the browser tab. And you see what I've shown you so far in the screenshots. So the other thing is, maybe if I look at packets.json for this little mini project, again, there's very little in it. I have React, obviously. I have Bootstrap. I'm not sure if I actually need that. I'm not sure if you need it for the exercises that you would have to do, but other than that. And I have Storybook as well. Again, for those people that may not have done any JavaScript, there are two types of third-party modules that you might need when you're doing JavaScript development. There are those modules that form part of your application, which these three would be. We call those dependencies. And then there are third-party modules that you use that are only required when you're doing development. And in our case, that would be Storybook. Storybook is not obviously going to be part of my final React application that might be deployed to a cloud server. It doesn't need to have Storybook as part of it. So anyway, I've got these three dependencies as well. In a package.json file, you can put in what are called scripts. And scripts are essentially kind of shorthands for commands that you might want to run from the command line. And I've got a script which I've called Storybook. And this is the script that will actually start the Storybook server for me. So as an alternative to using my script, I could type this long command from the command line, and that would start up my Storybook server. You've got to tell it, well, what port do you want the Storybook server to be running from? And you've also got to tell it here, you've got to tell it where is the Storybook configuration files, which in my case is inside in that Storybook, as we saw. So if I start up the Storybook server, maybe make that the next thing. So that's my script up here, and to run, that's my script. And to run a script, you just go npm. I've already done the npm install now beforehand, so that everything, all my dependencies are installed locally. Although you can see the node modules folder over here, but I think I've installed them already anyway. And what you'll see now when I hit return is it's now essentially what's happening down here is it's transpiling all of the files, open up a browser tab, and here we go. Now, again, I've decided to break my stories up into two files, one called samples and the other called exercises. And that's why you see over here, you've got exercises and you've got samples down here. And here are my sample components that I need to step through now. I think this is the one that we've looked at so far, but here I go clicking on my components and I can see that they're rendering properly. The exercises ones are all to-dos for now. So for the rest of this lecture, I need to step through these stories here and the associated components, I guess. Right, I'm just checking my watch. So the first thing I want to explain is how do we embed variables in JSX? Because up to now, our JSX has been static. And so the answer is you can embed variables by just wrapping the variables in curly braces. And so when React sees curly braces inside in the middle of JSX, it will evaluate what's inside the curly braces and make that part of the overall JSX, if you like. And a bit like in string templating, you can actually have any kind of expression you want to inside the curly braces, like invoking a function, etc. And so the screenshot here shows you a very simple example in that I'm just declaring some variables. Okay, they're internal to the component for now, but that'll do for now. Eventually we'll pass them in. And I've got an array and I've got a string. And here's my JSX. And here it looks like I'm embedding something. I'm embedding an expression. In this case, what I'm doing is I'm using string templating to construct a string. So all of this has to be evaluated. first of all, before it can be part of the eventual JSX. But it's an ordinary string template. So I'm taking the variable header and using string templating syntax to evaluate that variable. And that then the output of this entire expression becomes the text for my H1. And here it looks like I'm indexing into my array of languages that I've defined up here. And I'm just dereferencing them. It's not a great improvement, but it's a slight improvement. And this is sample 2. So as simple as all as it is, if we look at the component first, so again, the components is also split up into 2 subfolders, examples and exercises, or sorry, samples and exercises. So it's the samples folder I'm interested in. And it's the 02 one. Okay, so we've seen that. There's my component. The story is not too interesting, but we look at it anyway. The story is inside here, I think. Here's the story. And that's the rendering. Okay, so I have my, so I'm going to keep that file open now because I'm going to keep coming back to it. So again, I'm taking small steps. Here's my component implementation, but I want to see, will my component render properly? So I write a story about it. There's my story. Then I fire up my storybook server, and it allows me to actually click on that story and see that the component renders properly. But the example is all about how do you embed variables within your JSX, and you just wrap them in curly braces. Next, we want to make so far our component is completely enclosed. We can't actually pass anything into it. And if we could, then possibly the component could be used for different contexts. In other words, we want to make the component reusable. And so the answer to making your component reusable or parameterizing the component is to introduce what are called props. So a component's props are properties or attributes or parameters that we pass into the component. And there's 2 things. A, we want to find out how do we pass props or properties into a component, and B, how do we access those properties inside in the component? Well, the first one is how do we pass props in, and we've actually seen it already, but we use this key value syntax, which is a very HTML-like syntax. So this is the name that I want to give to the parameter or to the property. Give it anything you want to. The value that you assign to it, you have to wrap the value in parentheses, in curly braces, sorry. That has to be evaluated first because there could be an expression here. But even if it's just a static value, you still have to wrap it in curly braces. And whatever other properties that you want to. So again, this is actually part of the design process of a component, deciding what properties should this component have that will benefit us in terms of its reusability. So that's how you pass props or properties in. Inside the component, then, how do you actually access them? Well, it turns out our component function by default has an argument. You can call the argument anything you want to, but the convention is to call it the props argument. So this is an object, and it's actually constructed at runtime by the React framework. And this object will have key value pairs corresponding to the key value pairs that you have expressed here. So this props object is actually constructed dynamically at runtime, because obviously every time we use our component, okay, the prop names will be the same, but the values will be different. So this props object is constructed at runtime by React. And then we dereference the keys inside in the object in the normal kind of JavaScript way. So it's my object using the, in this case, the dot syntax to get at the particular value and do whatever you want to with it. Very important, these props are immutable. You cannot change the props inside in the component. In fact, you get, I think you get a warning error if nothing else, but you cannot change them. The whole notion of props is that they are not changeable by the component. And number two, I'm saying, yeah, I've already mentioned number two, they're part of the component's design. So just by way of an example, if we look at the 0.3 example, and maybe if we look at the story first, all of the samples essentially do the same kind of thing. They just display an array of languages, I think in most cases. But so here's sample 3, and okay, I'm just declaring a variable here. Oh yeah, so I'm passing in, here's my component, I'm passing in 2 props, which I've decided to call languages and heading. Languages is assigned to the variable list, which is specified up here. And the component itself, then how do we find the component? Well, I've said we call the component that, and if I look up at the top at my imports, you can see that it's coming from this file here, which brings me over to here. Here's our component implementation. Here's my props function argument, and here I'm dereferencing into the props object. Any questions about that, I wonder? The only thing you don't see in anywhere in this little project now is an invocation of React DOM.render. We don't need to use that with Storybook. Storybook takes care of attaching components to DOMs, and it kind of does that really based on, you know, which particular story do you click on over here. It will deal with attaching that component based on the story to the DOM, which allows us to see it rendering here. Just by the way, if you look through all of the samples, you'll see that in each case, I'm calling the component demo. That's just purely a convenience. Right? Normally, the convention would be that the component name would be the same as the kind of file name that you've put the component implementation into. It's obviously the case that you would have one component per file. You could have more, but it's very rare. It would be, the convention is to just have one per file. And also, it's not conventional, but okay, I'm exporting demo here. But when I'm importing it inside in my story implementations, when I'm importing it, which I am in this line here, I'm calling the component something else. That would be non-standard as well, but it's from a JavaScript point of view, that's allowed. That's this idea of props and reusability, essentially passing data into a component. But we will see later on that you can pass functions into a component as well. So you can actually parameterize the behavior associated with a component by passing in as a prop some of that behavior in the form of a function. That's a long way down the line though. Before I show you the next example, there are just one or two little aspects of JavaScript that I need to remind you of, even though it was on last week, as it turns out. But you might remember from last week that when you're using the arrow function syntax, then you can remove a lot of the syntax associated with the arrow function in certain cases, like if there's only one statement in the body of the arrow function, if that statement is its return value, etc., etc. So you might remember all of that from last week. It's not too long ago. So instead of implementing an arrow function, this particular arrow function using all that extra syntax, we can actually rewrite it like this. So just remember that when we look at the next example. That's the first reminder. The second reminder is the array.map method, which allows us to map over an array, source array, and produce an output array from it. And we've seen that last week as well, as it turns out. So it's fairly fresh. The third thing, which is more JSX related, is it's perfectly acceptable now to assign a piece of JSX to a variable. That assignment statement is a normal assignment that you might make in a React component implementation. And at first viewing, that looks odd. And I'm posing the question here, why do you think that it is actually possible to do that? It's kind of a question that I'm putting out to you, and I'll give you a hint. The hint is transpilation. So the answer is, if you take that and you transpile it, you get that. And so all we're doing is we're calling a method on an object, and whatever that method returns, we're assigning that to our variable. That's a perfectly normal piece of code to write. So when we write our code like this, it's transpiled into this, and so it now becomes a perfectly normal piece of JavaScript code, a normal kind of JavaScript assignment statement.
Can I ask you a question? Can that div, that first div tag, can that be on the line below?
Yeah, there's no problem. And in fact, I'm not sure if you should actually wrap it, the entire snippet in parentheses. Sometimes you do, sometimes you don't, which is not a great thing to say. But but by putting that onto new line, that won't make any difference. That's just white space really between the equals and what you're assigning to it. It's a bit like saying, like, if I hit the return character here, that's not going to change anything.
So then it makes it like normal HTML to, the people who know HTML.
Yeah, I think so. Yeah. I've obviously picked a very simple example, but I could have inside here, I could have actually a reference to a component, another component of mine here, where I would be passing props to that component. So I've just decided to show ordinary HTML, but as we'll see at some stage down the line, this snippet here could actually be referring to other components of mine. And that's where we've got this kind of notion of composition going on, amongst other things. Yeah. So taking those three things on board, the next example, which is a pattern that we'll see quite a lot, is supposing I want to generate a collection of components, or I want to have an iteration of components. So we've got a component and its prop is an array, which you've seen already, but we wanted to use that array in order to generate a collection of JSX elements. The example is actually, we wanted to generate this for us, but to generate it kind of dynamically. Up to now, we've been kind of doing it statically. So we want a component which generates this within its behavior, if it's like within its within its behavior. It actually generates an array of Li elements, and the number of entries or the number of Li elements will be dictated by an array that is passed into it as a prop, and it iterates over that array. It's an ordinary array, data array, and it uses that data array to generate some JSX output. So we'll totally look at sample 4. And the approach I'll take is, let's see what sample 4 renders first. Kind of looks familiar, but these are clickable, which, okay, these are, looks like they're hyperlinks. To save boredom, I've switched over to single page app frameworks, right, rather than languages. So we want to look at the component that actually generates this as its UI description. We look at the story first. Not really any surprises, I don't think, in there. So we're up to 0.4. Okay, so I'm passing in just a string, and I'm passing in an array. So this is an array that I've declared up here. So I've constructed this array, and it looks like it contains objects where each object has a framework name and it has a URL to that framework's homepage. Okay, so that array is passed into my component, and it generates what I showed you. But the array, can be of any size. It doesn't have to be 3. So our component now is getting more flexible, if you like. And let's look at the component. Well, sorry, before I do that, right? Like if I take this, and let's say I double up the size of the array. Sorry, now. Just going to take these two, let's say. So all I've changed is the story. I haven't changed the component, which we've yet to look at, but assuming there's no syntax errors, my component has dynamically readjusted to how many framework details were passed into it. So it must be generating this list internally itself. Okay, enough of the suspense. Let's look at how it does it. Am I looking at the right one? I'm not, sorry. Bad start.
This will give you the ability to put all your dummy data into that storybook.
Yeah, you would tend to do that anyway, though. The dummy data would be part of your storybook file. You could grab it remotely, but it wouldn't be common. Like it's essentially kind of test data. Yeah. So here's the component implementation. Oh God, sorry. What did I just do? And here I'm referencing the array via the props object, and I'm mapping over it. And we have a sense of what the array contains now. Yeah, it's just the array of objects. And we know from the map that we pass it a callback. So F there is going to refer to one of the objects in my array that I've passed in. and indexes the position of that object in the array. And here's what the function returns, what the callback that I'm passing to map returns. It returns a piece of JSX. So this variable here, when the code completes executing, the list variable will be an array because we're using map. It will be an array of elements where each element is a snippet of JSX. But of course, when this gets transpiled, this becomes an invocation of react.createElement and all that kind of stuff. But sometimes you're better off not thinking back to, well, how does this transpile? You kind of, if you want to start thinking in React terms, you kind of have to accept, okay, I've got an array of JSX snippets. Just as I could assign a JSX snippet to a variable, then I can have an array of JSX snippets by the same argument. So that's what list is going to be. It's going to be an array of these things. And then in the body of my component, I'm not doing anything special. Here's just where I render the array. When you've got an array of JSX elements, if you want to render them, you just wrap them in your curly braces as before, because we want to dereference the contents of that variable. If we took out the parentheses, then all we would see in the component rendering is the letters LIST. So this is a pattern now that you would see quite a lot, where a prop is passed into a component. The prop contains an array of things. We map over that array in order to produce how we want the array to be rendered in the browser. And in this case, I want each entry in the array to be rendered as an LI element. Let's actually look at the LI element in a bit more detail. So it's an LI element, a list element, which is normally HTML thing. Let's just ignore the key for a second. And in my LI element, I have an anchor tag, which is again a HTML thing, which has a href property, HTML, and I'm grabbing the URL associated with the current object in this frameworks array that was passed into me. And we saw what the array looked like, which was, you know, this here. So there is a URL property that we can get at. And so I guess that there is what generated my hyperlinks here. And the dots are just because it's an unordered list. The only thing that does perhaps need to be explained is what is the role of this here? It's just a React recommendation rather than necessity, which is if you have got an array of JSX elements anywhere within a React app, each element in that array should, rather than must, should have a unique identifier. You can call the identifier can be anything you want it to be. It makes sense that I've actually used the index position as the identifier within this little array. That will be unique, and you assign that identifier to the prop called key, and it's actually used internally by the React framework within the browser when it's kind of rendering your component. It doesn't really play any role in terms of how the component renders, but it does help React to improve its performance. That's a very big statement now without getting into explaining it. But if you took it out, your component would still render fine. But if you open up the developer tools, you would see a warning message from React advising you that you'd probably be better off having a unique key identifier for each entry in the array. So that's rendering a collection of JSX snippets and generating that collection dynamically usually based on an array prop that's passed through into a component, but it doesn't have to be. The screenshot here, actually, that's just coming from my browser. In other words, I don't know if you're familiar with, well, the developer tools, but the developer tools have a lot associated with them. But one thing you can do with the developer tools is if you click on this little icon here, and if you mouse over a particular part of the web page, then what you will be given on the right is the HTML corresponding to that part of the page that you clicked on. And so that's what we're seeing over here. Yeah. Here's our set of LI elements. And so all I did was I just expanded those, and that's what gave me the screenshot. And that feature of the developer tools in the Chrome browser may be useful to you down the line. If sometimes you do actually want to see, well, the JSX component, sorry, the component that I've implemented, what actual HTML did it generate for the browser? And is it what I expected? And so the developer tools will allow you to explore that, I guess. So again, the sequence is open up your developer tools, click on this icon here, and then mouse over the particular part of the page that you're investigating. And you'll see then, you'll be taken to the actual part. Essentially, this is kind of part of the DOM. What you're seeing here is the DOM structure, although we know that the DOM is a JavaScript object structure, but that wouldn't be very helpful to us. We'd like to see the DOM in its kind of HTML representation, and that's what you're seeing here on the right. Now, a component returns JSX, but I suppose it's obvious in one sense, but sometimes we will make a mistake. A component can only return a single JSX snippet. And so I've just some examples here, some of which aren't very useful though. But so that's a valid return statement, maybe from a component, because that is a single JSX snippet, albeit static. This is fine as well. So it's possible that a component may return another component as part of its UI contribution. This is even more likely, where you've got a component returning a larger snippet, but this is still a single JSX snippet because I've wrapped it in a div. If I take out the divs, now I'm going to get a runtime error because I'm now trying to return more than one JSX element. I'm trying to return a H1 and a UL, and you will get an error in that case. And also, well, this comment down here, if you've got multi-line, a multi-line JSX snippet, then you need to wrap it in parentheses, essentially kind of to help the runtime, the framework's runtime to evaluate it. You must return only one element, which I've already emphasized. If you do something like this, then you're going to get an error, which I've already mentioned. This is the actual error. And you may well make this mistake at some stage. It's very important, actually, by the way, to always have your developer tools open when you're doing your when you're in development mode. So to see what's happening, and so you would see this error. And when you see this error, and the error is quite informative, it's essentially telling you that you need to wrap your JSX in, usually in a div is how we fix this problem. Just wrap this in a div and problem solved. That does mean, though, that in the early days of React, that's how we did it. That's how we solved this this problem by just introducing a div. But of course, in a very large React application where you could have hundreds of components making up your entire application, that is adding a lot of divs to the overall HTML structure that's making up your app. And so your HTML, its depth is going to be quite significant. And the deeper your HTML data structure is, and that impacts on the size of the DOM, that does or it can affect the performance of your React app. And by performance, I simply mean how quickly it can actually render a page in the browser and update that page based on the user interaction. And this was a problem in the early days of React because of all these additional divs that we had to introduce. And so what they did was they gave us a new tag called the fragment tag, which is this one over here. So this has the same role as what the div is doing. It's wrapping all of this into one JSX element. And what's nice about this fragment tag is that it doesn't contribute anything to the DOM structure. And hence it doesn't, you get a slightly better performance. Only an issue really for very large applications, but you'll see me using it quite a lot in my code, and so just making you aware of it. Every React application that you will ever develop will always finish up as a hierarchy of components. There will be a component at the top of the hierarchy. It will have children. Those children components will have their children, and on it goes. It will always be a hierarchy of components. It doesn't have to be a balanced hierarchy, but you just cannot get away from this fact when you're designing any React application. So components have children, and that's really modeled on the whole HTML idea as well. You can have nesting of HTML tags within HTML tags. Similarly, you have nesting of components. And so by way of illustration, again, it's a kind of a made-up example, but I've got a component which renders like this. And when we look at the implementation of this component, there are actually three parts to it. There's the component at the top of the hierarchy, and it has two children. One of its children is responsible for contributing this, and another one of its children is responsible for contributing this. It turns out, in this case anyway, the component at the top of the hierarchy, as well as using these two children components, and presumably it passes props down to them, but the component at the top also contributes some stuff itself to the overall UI. That's just, again, for the purpose of illustration. Usually the component at the very top of your hierarchy, and indeed maybe its children and grandchildren, may not actually contribute anything directly to the UI. They're mainly concerned with managing lower level components. By managing, I mean passing props down to them and updating those props when needs be, usually based on the user interacting with the application. So this is 05. And again, we'll take the approach of looking at the story, I suppose. Same kind of pattern now. So I've got some test data. I've got this large object which has some key value pairs along the lines of that. And here's my component, and I'm passing some data down into it. I'm passing this kind of large enough little data structure down into it. and the component then. Nothing new really in this one. It's just bringing together a lot of what we've already seen. So here it is, and it's taking the props and it's digging into the props, and it looks like it's using another component that I've developed, this one here, which was one that we've already looked at, the iteration one. And it's also using this component, which is one that we developed earlier on, the 03 props one. And so this component, its overall contribution to the UI is all of this, but it's delegating, if you like, it's delegating down to these two subordinate components, the responsibility of rendering part of the UI. It's contributing this itself to the UI, and it's contributing this to the UI. So I would say that in this small little substructure, this component here is at the top of my hierarchy, and it has two children. Even though arguably it's a straightforward example, there's a lot going on there now, and you would need to, it's still static, but in terms of the volume of code anyway, there's a lot going on there. So you need to have a look at that yourselves. So that's props, that's iteration, that's component hierarchy. And in the first of this week's labs, I essentially give you a series of little exercises, and the exercises require you to implement a component. I actually provide the stories, but you should look at the stories. Maybe if I just flip over to it. I think I give you all of these files, but all of them are not implemented. So you've got to fill them out. And I've given you the stories, as I said. Which you can look at. You won't need to change it. I think the only thing you might change is, the idea is that you have a list of modules here associated with your course, but you can change these maybe to reflect your module titles, but other than that, you can leave the stories alone. You won't need to go near the actual stories themselves, but as I said, have a look at them. That's that lab. I'll just pause for a second. I've kind of ran through quite a lot there now. Are there any lingering questions before I move on? Can I move on? Oh my God, I can't. Oh God. Okay. Material UI, not going to get to cover, unfortunately. So be it. Let's see. Yeah, it's a pity now because the material UI stuff comes in here at the back end of it, but it's all right. I'll let you sink or swim with it. Maybe it's going to be important now for the rest of the module, admittedly, but I'll cover it the next day with you. I'm right when I'm reading my clock, aren't I? I am, yeah. All right, Sinead, I think for today. Are there any remaining questions, I wonder? Oh, sorry, I'll just expose my camera. Now, some of you were asking me for an assignment specification for assignment 1. I'll put that up tomorrow morning. I have it done all right. I didn't want to put it up before the lecture because I don't want to be handling questions related to it. I wanted to get through as much of the slides as I possibly could, and I didn't get through all of them, but that's all right. But I will put up the assignment specification. Now, the assignment obviously has got to do with React. We've only started React I don't expect people to start working this out until about at least another 2 weeks of material that I need to cover. But some of you may have some prior knowledge of React, and so that's fine. You can have a look at the spec, and if you've got any questions for me, you can put them to me on Thursday. I don't think, are you aware of this next week not having any new content? I don't know if somebody may only be doing one module, but there was kind of a decision made at the department level that there would be no new content presented to students, undergraduates or postgraduates next week. So unfortunately for me anyway, I prefer to give a lecture next week, really, so to get you up and running with the React stuff. But so there won't be a lecture next week. And I might actually provide you with another lab that you can work on next week. And the lab will be the first of 4 labs where we build up our Movies fan app. Now the lab does use that Material UI framework that I hoped to get through today, but I'll decide later on in the week whether I actually provide that extra lab to you or not, and I'll inform you on Slack. Right. Any last minute questions, or we wrap up? No. Okay. So I'll see you on Thursday. Bye for now.
Okay.